Section 1.6 is on measuring angles. Okay, when we talk about angles, they are simply two rays that go off from the same point. We call that point the vertex. So we've got a ray going off this way and a ray going off this way. That's what makes an angle. When we name angles, they are made using points. So we're going to use capital letters. We will use points A, B, and C in this case. I could name this angle, angle ABC. I use the angle symbol and then write ABC. That's an appropriate way to name this angle. I could name it backwards, CBA. One thing that you'll notice is that B is the center in both of those names. That's because the vertex has to be the middle letter. Okay, order counts in an angle. So if you say CBA, it's the angle that starts at C, goes through B, on its way to A. If you say ABC, it's the angle that starts at A, goes through B, on its way to C. So B has to be the middle letter when you name it. If this angle is the only angle in the picture that has B as a vertex, then you can simply call it angle B. That's an appropriate way to name this angle. Now, if you have a picture, for example, like this, where at the vertex you have 1, 2, 3, 4 angles, then you cannot name an angle angle B because I wouldn't know which angle you were talking about. So, but if it's the only one, then you can use just the vertex if you want. Another way that you will see angles named in pictures is, for example, sometimes there are several different angles. Let's say in this picture there's a 1 and a 2. You can, if they have numbers in here that are not the degree measures, not what they measure, but if they're just numbered in here, if there's just little numbers floating around in here, then you could call this one angle 1. You would simply draw the angle symbol and write the number 1. Or in this one would be angle 2. A lot of times the ones that are numbered this way won't have any letters on them. Okay? For example, this one has A, B, and C. These ones don't have any letters on them. And so they just have this number floating around in the middle. It's not a degree. It doesn't have a little circle to show a degree. So we would call it angle 1 or angle 2 in that case. So those are different ways that you can name angles and describe them to somebody else. Okay, some classifications of angles. It's an acute angle if it's less than 90 degrees. You should know that a 90-degree angle, looks like this, looks like a perfect square. In fact, a lot of times they'll actually draw a little square in there to show that it's 90 degrees. An acute angle would be smaller than this. Okay? An obtuse angle would be bigger than 90 degrees. And a straight angle will look like a line because it'll be exactly 180 degrees, which makes it a line. Okay. All right. Some definitions that you need to know about angles. We talk about complementary angles. Okay? Complementary angles are two angles that if you put them together, they would add up to 90 degrees. For example, if this one is 30 degrees and this one is 60 degrees, then they would add up together to be 90 degrees. Complementary angles can look like this, where one's in one spot and one's in another. Another way that they can look is if you have a right angle and then you have a ray coming out of the right angle, we would say that this angle, the top angle, and the bottom angle are complementary. You can see that if you put them together, they make 90 degrees. So that would be another example of what complementary angles would look like. Supplementary angles basically work the same way, except that they go to 180. So these two angles, angle 1 and angle 2, would add up to 180 degrees. Angle 1 might be 110 degrees, and angle 2 then would have to be 70 degrees, so that when you added them together, they would add up to 180 degrees. Okay? Again, they can be away from each other, like these two are not connected, or they can be adjacent. They can sit next to each other, okay, like these ones. And if they sit next to each other, they would look like this. They would look like a straight line, and then there would be a ray coming out of them somewhere. Those two angles would be supplementary. Okay. The word adjacent simply means next to. So when we talk about adjacent angles, we're talking about angles that look like this. And this angle here sits right next to this angle here, so they would be adjacent angles. They have to share the same vertex, however. It can't look like this, where you've got one angle and then this angle comes out over here. That doesn't work. Okay? They have to share the same vertex in order to be adjacent. Vertical angles. Vertical angles are angles that sit across from each other in an X formation. So anytime you see two lines that intersect, they form four angles. This one here is vertical with this one. Notice that they sit across from each other. And then this angle here and this angle here are vertical angles. They sit across from each other. So one pair of vertical angles, two pair of vertical angles. They sit directly across from each other. Vertical angles always form an X. The last thing we're going to talk about is congruent angles. Those are simply angles that have the same measure. Okay, so if this one is 89 degrees and this one is 89 degrees, we would say that those are congruent angles. One way to show congruent angles is by using little arcs. Remember when we had congruent segments and we made tick marks? Well, congruent angles kind of do the same thing, only with congruent angles, you make these little arcs. Okay? So that little arc being in both of those places means that the measure of this angle is the same as the measure of that angle. That's how congruent angles work. One way we have to measure an angle is using a protractor, okay, which I have up in the classroom. You simply take your protractor, you put the T part of the protractor, sometimes there's an actual hole there, but a lot of times it's just a T. You put that intersection on the vertex of the angle. And then you line up the bottom of the protractor. There'll be a line here that says 0 on it. Okay, notice it goes all the way across. You put that on the bottom line of your angle, and then wherever the 0 is, you read up. Okay, now, common mistake, kids look at this and they go, ooh, right here, it's got to be 106. That's right, that's the line it goes through. 105, the next one over is 106. This must be 106 degrees. Now, if I take that protractor away, what do you notice about that angle? Well, it's not quite 90 because it doesn't make the square. So how can it be 106 degrees if it's less than 90? And the problem is, notice that there's two scales on a protractor. Make sure you're using the correct scale. Okay? When you're measuring an angle, you wouldn't start at 180 and count backwards. You would start at 0 and count up. So go over here, 0 and up, that gives us 74 degrees, not 106 degrees. Okay, so be sure that you are careful when you are measuring with a protractor that you're using the correct scale. One more thing, here's an example. Here, angle, look at this picture. If I said angles 1 and 3, how would you describe them using these words? They could be vertical, supplementary, complementary, congruent, or adjacent. Okay. If I talk about angles 1 and 3, I would say that they are adjacent because they're right next to each other, and I would say they're supplementary. because if I put 1 and 3 together, I make a straight line. So I would say that angles 1 and 3 are adjacent because they share a side here, and they're supplementary. Angles 1 and 2, I would say are vertical. They actually are also congruent if you recognized that, but if you didn't, we won't talk about that until the next chapter. But in case you recognize that, those are congruent. Angles 3 and 4 are also vertical. They sit across from each other, and they're also congruent. Like I said, I'm not too concerned about those right now. If you can get that they're vertical, that's what's most important. All right, over here, angles 5 and 9, there's supposed to be a square right here. But since there's a square here, that means that this angle's 90, and notice that it makes a straight line here. So that means this one's 90. It makes a straight line with 6, so 6 is 90, which means 5 and 9 together have to be 90. So what do we know about angles 5 and 9? We would know that they're complementary and adjacent. They're next to each other, which makes them adjacent, and together they make 90 degrees, so they're complementary. 8 and 6 sit across from each other. They are vertical angles and congruent. And 7 and 8 make a straight line, so they are supplementary. They're also both 90 degrees, so they're congruent. And they're adjacent because they sit next to each other. So 7 and 8 have all kinds of relationships. The last thing we're going to talk about today is the angle addition postulate. Angle addition works a lot like segment addition. It says that one smaller angle, if you add it to another smaller angle, you get a bigger angle. Okay? So if this one was 30 degrees and this one was 40 degrees, we would say that 30 plus 40 would equal 70. So the measure of angle ADC would be 70 degrees because it would be the combination of the two smaller ones. Okay. How do we use that? Because you know I'm going to put in the algebra. For example, here, this angle plus this angle, it doesn't say how much the bigger angle is, but in the picture you can see that they form a straight line together. So what does that mean? What does that straight line mean? It means 180 degrees. So I would say that if I added the 3x plus 4 to the 5x plus 16, if I added those two smaller angles together, they would have to equal 180 degrees because together they make a straight line. And then from there, you do your algebra. 3x plus 5x is 8x. 4 plus 16 is 20. Minus the 20. So 8x equals 160. Divide by 8. X is 20. So if x is 20, 3 times 20 is 60 plus 4 is 64. 5 times 20 is 100 plus 16 is 116. So you can always double check yourself and see that if your answers, does 64 plus 116 actually add up to 180? Yes, it does. I did it right. Okay? Same thing here. Look at the picture. What does this square mean? Means 90 degrees. So I'm going to take x plus 37, and that means together they're going to add up to 90 degrees. So I would minus my 37, and x would be 53, which means this angle would be 53 degrees. Okay. Sometimes they won't put it in picture form. They'll just tell you what each one represents. In that case, draw it and write them in so you can see it. Okay, it says that ADB, the measure of angle ADB, is 2x plus 10. It says that BDC, the measure of angle BDC, is 3x plus 5. And then it says ADC, the whole thing, is 10x minus 5. So using angle addition says you add the two smaller ones together and equal them to the bigger one. So I would add 2x plus 10 to 3x plus 5, and that means it would equal 10x minus 5. And I would do my algebra. 2 and 3 is 5x, plus 10 plus 5 is plus 15. I would minus my 5x over here. I would add my 5 over here, and x is 4. So that means that the value of x has to be 4 for this problem to work. So 2 times 4 is 8, plus 10 is 18. 3 times 4 is 12, plus 5 is 17. And 10 times 4 is 40, minus 5 is 35. So 18 plus 17 equals 35. Yep, we did it right. Okay, I know I went through those kind of fast. I have to limit my video lengths in order for them to work. So here are your lessons, or excuse me, assignments for the section.